Friends, welcome to my YouTube channel. Dhanesh here. Today we are going to discuss about ensemble models. This is the second video on ensemble models. The previous video, the first video, was an introduction to ensemble models. Today we are going to discuss about bagging, boosting and stacking in detail. Let's start. Ensemble models, we already discussed. Ensemble models combine the decisions from multiple models to improve the overall performance. This can be achieved in various ways. Ensemble methods are meta-algorithms that combine several machine learning techniques into one predictive model in order to decrease variance, that is bagging, and bias. To decrease bias, we use boosting, or improve predictions, we use stacking. This is important. To decrease variance, we use bagging. To decrease the bias, we use boosting. To improve predictions, we use stacking. These are all the three types of ensemble models here we are going to discuss. The principle behind these ensemble models is the main principle behind the ensemble model is that a group of weak learners come together to form a strong learner, thus increasing the accuracy of the model. When we try to predict the target variable using any machine learning technique, the main causes of difference in actual and predicted values are noise, variance, and bias. Ensemble helps to reduce these factors except noise, which is an irreducible error. We cannot, rectify, or we cannot, work on noise. Variance and bias, those two things are rectified by using the ensemble models. Types of ensemble models. Ensemble methods can be divided into two groups. One is sequential, example boosting, and parallel, example bagging. There are sequential ensemble models and parallel ensemble models. Boosting is an example for a sequential and bagging for parallel. We will discuss. Sequential ensemble methods where the base learners are generated sequentially. Example AdaBoost. The basic motivation of sequential method is to exploit the difference between the base learners. The overall performance can be boosted by weighing previously mislabeled examples with higher weight. Parallel ensemble methods where the base learners are generated in parallel. Example random forest. The basic motivation of parallel methods is to exploit independence between the base learners, since the error can be reduced dramatically by averaging. Different ensemble techniques. These three techniques only we are going to discuss here. Stacking, to increase the predictive force of the classifier, to increase the prediction. Bagging, to decrease the variance. Boosting, to decrease the bias. Algorithm based on bagging meta-estimator and random forest are algorithms based on bagging. Algorithms based on boosting, AdaBoost, GBM, XGBM, LightGBM, CatBoost, etc. Boosting is a general ensemble method that creates a strong classifier from the number of weak classifiers. So let's discuss in detail about boosting. Boosting is often considered homogeneous weak learners. Here you need to understand, in bagging and boosting we use homogeneous weak learners, but in stacking it's heterogeneous. So boosting is often considered homogeneous weak learners, learns them sequentially in a very adaptive way, and combines them following a deterministic strategy. This is done by building a model from the training data, then creating a second model that attempts to correct the errors from the first model. It's simple. Models are added until the training set is predicted perfectly or a maximum number of models are added. AdaBoost was the first really successful boosting algorithm developed for binary classification. AdaBoost, it's the very important algorithm for boosting. It is the best starting point for understanding boosting. AdaBoost. Very important. Boosting is a sequential process we already discussed. Boosting is a sequential algorithm where each subsequent model attempts to correct the errors of the previous model. The succeeding models are dependent on the previous model. As discussed, unlike bagging that mainly aims at reducing variance, we discussed, boosting is used to reduce the model bias. Boosting, like bagging, can be used for regression as well as classification problems. This both boosting and bagging, you can use it for regression and classification problems. Both boosting and bagging you can use. Two important boosting algorithms are AdaBoost and gradient boosting. These two are the two important boosting algorithms. Boosting is used to create a collection of predictors. In this technique, learners are learned sequentially, with early learners fitting simple model to the data and then analyzing data for errors. Consecutive trees, random sample, are fit, and at every step, the goal is to improve the accuracy from the prior tree. This is very important. When an input is misclassified by a hypothesis, its weight is increased so that next hypothesis is more likely to classify it correctly. This process converts weak learners into better performing model. That is boosting. Advantages of boosting: support different loss functions, works well with interactions. These are all the advantages. Disadvantages: it is prone to overfitting, requires careful tuning of different hyperparameters. Algorithms based on boosting, as we discussed, AdaBoost, GBM, XGBM, Light GBM, CatBoost, etc. Next is bagging or bootstrap aggregation. Bagging is also known as bootstrap aggregation. Bagging often considers homogeneous weak learners. Even bagging and boosting, we consider homogeneous learners. Weak learners learns them independently from each other in parallel. Here it is in parallel. In boosting it is sequential, and combines them following some kind of deterministic averaging process. Very roughly, we can say that bagging will mainly focus at getting an ensemble model with less variance than its components, whereas boosting and stacking will mainly try to produce strong models less biased than their components, even if variance can also be reduced. Now, bagging is used when goal is to reduce the variance of a decision tree classifier. Here, the objective is to create several subsets of data from training sample chosen randomly with replacement. Each collection of subset data is used to train their decision trees. As a result, we get an ensemble of different models. Average of all the predictions from different trees are used, which is more robust than a single decision tree classifier. So bagging, it is see, these are all the algorithms based on bagging meta estimator. Random forest is the most important algorithm for bagging. Advantages of bagging: reduces overfitting of the model, handles higher dimensionality data very well, maintains accuracy for missing data. Disadvantages: since final prediction is based on the mean predictions from subset trees, you don't give precise values for the classification and regression model. Similarities between bagging and boosting: both are ensemble methods to get n learners from one learner. Both generate several training data sets by random sampling. Both make the final decisions by averaging the n learners. These are all the difference between bagging and boosting. First one, bagging, simplest way of combining predictions that belong to the same type. Boosting, a way of combining predictions that belonging to different types. Bagging aim to decrease variance, not bias. Aim to decrease bias, not variance. Each model receives equal weight. Models are weighted according to their performance. Each model is built independently. New models are influenced by performance of previously built models. Different training data subsets are randomly drawn with replacement from the entire training data set. Every new subset contains the elements that were misclassified by previous models. Bagging tries to solve overfitting problem. Boosting tries to reduce bias. If the classifier is unstable, that is high variance, then apply bagging. If the classifier is stable and simple, high bias, apply boosting. So these are all the difference between bagging and boosting. Now we are going to discuss about the last one, stacking. Stacking often considers heterogeneous weak learners. In bagging and boosting, it was homogeneous learners. Here we use heterogeneous weak learners, learns them in parallel and combines them by training a meta model. This is important to output a prediction based on the different weak models predictions. As we already mentioned, the idea of stacking is to learn several different weak learners and combine them by training a meta model to output predictions based on the multiple predictions returned by these weak models. So we need to define two things in order to build our stacking model: the learners we want to fit and the meta model that combines them. For example, for a classification problem, we can choose a weak learners as k nearest neighbors, logistic regression, and support vector machine, and decide to learn a neural network as meta model. Then the neural network will take input as take as inputs and the take as inputs the outputs of our three weak learners and will learn to return final predictions based on it. That's all about bagging, boosting, and stacking. Thanks a lot. Thanks for watching. Please like, share, and subscribe. Thanks a lot.